Okay, so 3.1 specifically asks us to graph the parabola, the quadratic equations. This is standard form, kind of book talk for what a generic form of parabola would look like. It is a quadratic equation, A, B, and C. We've talked about A, B, and C being real numbers, coefficients, what we use in that quadratic formula for a standard quadratic equation when it's equal to 0. So second degree, because it's x squared, x, and then the constant, it stipulates that A cannot be 0. If the first coefficient was 0, 0x squared, it would no longer be quadratic, right? It would be down to just linear, x to the first. So that's why it has that little extra note there. If it's truly a quadratic, you better not have just a 0 there as a multiplier, or your square term will drop out. All right, so for example, we've seen lots of quadratics already, right? Here's an example. A y equals 3x squared, 2x plus 5. Your A, B, C values, 3, 2, and 5. Another quadratic, y equals x squared, 3x, and 7. So A is 1, B is 3, C is 7. And then we've really talked about the simplest form of one, f of x, or y equals x squared, is your basic graph. We talked about how you shift around the basic graph in that form. So let's review that for these 3 examples. So the first one, just your regular y equals x squared. We talked about why it has this U shape. If you do a little t-table, you would see this to be true. 0 squared is 0. If you plug in 1, 1 squared is 1. 2 squared is 4. Plug in some negatives. Negative 1 squared is 1, that's why it bounces back up. And negative 2 squared is 4. So you can see the shape, 0, 0, over 1, up 1. Over 2 is up 4. Back 1 is up 1. And back 2 is up 4. And you can get more points to verify that. But truly, you can see that shape come alive if you do a t-table. Anytime you're in doubt about what a graph looks like, a t-table is the way to go to get some exact points and see that. All right, notice that this one is symmetric about the y-axis. We talked about symmetry last chapter, and this definitely has y-axis symmetry. Another way of saying the y-axis is to call that the line x equals 0. X equals, remember, is the vertical line equation. So x equals a constant draws a vertical line, and it's at x equals 0 value. So we will say that that's symmetric with the y-axis or the line x equals 0, because we're going to shift these, and sometimes it won't be exactly on the y-axis. And we say that this opens upward, and we call this lowest point the vertex. And when it's not shifted, the vertex is at the origin 0, 0. Okay, example 2. G of x, this time it's negative 1/2 x squared. So the negative flips it upside down, and the 1/2 makes it wider. Now, on Math Excel, you're asked to graph some of these, so you have to be more specific. You pick up your parabola tool, and you start it wherever the vertex is, and then it makes you find one more point on the curve. So if we had to do that, we would pick a number like maybe 2. 2 squared is 4, and then negative 1/2 times 4 would make negative 2. So you would also dot in positive 2, negative 2, to give it a more exactness to see how wide it is. So Math Excel will require you maybe to do a t-table point or two to get your curve in there more precisely. Notice it's still at the origin. The vertex is still 0, 0. Listen, guys, remember, if it is truly shifted away from the origin, you'll have a plus or a minus sign to do that. Just a multiplier times negative 1/2 only affects how wide it is or if it's up and down. So it's still the origin. All right, example 3. Now here's one that's shifted. So we do have the shifting rules. What's grouped with the x, we do the opposite. So it's shifted a positive 4. And then this is the vertical shift, positive 3. So that's our vertex. That's our starting point. Over 4, up 3. Because it's negative, we know it's an upside down, and 1/2 makes it wider parabola. And again, if I needed to be more specific, I would need to be careful and put in some points and see exactly how wide, not just throw it in there. However, some real good points to know in any graph are where does it cross the x-axis. If you were asked for for the x-intercepts, always and forever in graphing, the x-intercepts are when y equals 0. So I would plug in h of x, which is your y variable. 0 equals -1/2 x minus 4 squared plus 3. That would be how you'd find your x-intercepts. You'd have to do a little algebra to that. Maybe FOIL that out and distribute the negative half, get it in standard form, and then do your ABC thing, or factor it. But you have to solve that quadratic to pinpoint if you need to know those x-intercepts. It does look like it has 2 x-intercepts there. All right, so questions on that? Okay, let's flip the page. We're going to talk about how to tell where the vertex is if it's not in that nice graphing form. All right, so let's look where it says standard graphing form. Standard graphing form. Here's an example with the shifting rules, where we can see the vertex, -3, -2. All right, this same equation, let's say it wasn't written like this. This was FOILed together and distributed the 5 and minus the 2. If it was written like this, we would say that was standard algebraic form or standard polynomial form. Remember how we talked about a polynomial? We have the degrees in order, so it's all multiplied out. This is kind of a nice form, though. It's nice to see what degree it is, where the y-intercept is, if it's up or down. You can tell a lot from the standard algebraic form. But what we lose in the parabola is you can't tell where the vertex is. You can't tell what the shifting rule is. So I'm going to show you how to find that, and it's written like this. So instead of like that, this was your problem, and you were asked to graph that. What you do know is it's positive x squared, so it's upright and skinny, and you know the y-intercept. But the vertex is a critical point. You have to know that. So I'm going to show you 2 ways of doing that. It has to do with that completing the square, like we did with the circle. You could scoop the constant over. Now on the circle, we took the constant to the other side. Remember on the circle, the other side was the radius squared, so we had the other side where we could put our constants on. Here we're trying to keep y alone, y equals. So I just scoop the 43 over. Then to complete the square, I can't do it unless there's a 1 there, so I factor out the 5. Still have that 43 hanging on to the end. And then, now that that x squared is a 1x squared, you half the middle term and square it. So half of 6 is 3, 3 squared is 9. If I add 9, now that will factor into x plus 3 to the second, and it's looking like that way I tell the vertex. But anyway, I can't just add 9 to an equation without compensating. Normally we do it to the other side, but we're keeping this side alone. So what we do is, and it's really times 5, 5 times 9. We've added 45 to this side. So to compensate, I'm going to minus 45 from that same side. So adding an extra weight of 45 on the right side. If we also minus 45 from the right side, it's like 0. Nothing ever happened. So that gives me -45 and 43, which is -2. And now this is like the old form. And I can tell the vertex is at -3, -2. And it's skinny, and you can do the rest of it from there. Okay, so I wanted you to see the algebra of it, that you could do it without this little formula. But if you'll read at the bottom of the page, we do have a formula called the Vertex Formula that will find that for us without requiring us to go through all the algebra to completing the square. So let's take the same equation and apply the Vertex Formula, which says the first part of the vertex can be found at -b over 2a, and the second part of the vertex can be found at f of -b over 2a. A nice little formula. So as far as formulas go, that one's not too bad. So it says -b, it's in standard form, -30 would be your b, negative of b I should say, times A, 2 times 5 is 10. There's the negative 3. We're knowing this one now, right? The vertex is at negative 3, comma, negative 2. So this works. Negative b over 2a will give you the first part of the vertex. And then f of that means now you plug that back into the formula, or back into the function for x. So negative 3 back in for x, 5 times negative 3 squared, so on. That's what f of that. Plugging that value back into the function, plug it back in for x, work that out, and it is negative 2. So that is your vertex formula. If it's not in the standard graphing form where you can just look at the vertex by the shifting rules, negative b over 2a, and plugging that back into the function will do. How much time do you have?
6 minutes.